salmon.
Yeah, I was gonna say salmon.
I feel like salmon's pretty much the same. It's still in between red and white.
I just got here.
You dropped something.
Yeah, I did. It's not where my hug at. It's not.
I was stretching and I was like, keep going. You ready?
Dude, I feel horrible because I literally did all day.
You made waffles during one of your classes?
I actually did the stuff yesterday.
You told us.
Yeah, you sent it. Zoom to everybody.
Oh, yeah. I remember.
Disrespects to you. Was your camera on?
No. Nobody had their camera on, so I thought it would be awkward if, like,
Wait,
it's
what?
just me and her, and then she's, like, talking
Then
to
you
the
cooking
lesson.
waffles.
Good waffles.
Ridiculous.
You have like a stove in your room or something?
No, I did it in the kitchen. I just put,
I did the stuff
I
last
put,
night. I'm
wood
happy
on
with
the
this.
stove,
Hey, AMI sucks.
There's already distress in Mr. Townsend's face.
I got it.
I made
I got it.
eggs, waffles.
I'm ready for this.
I actually made it.
Honestly, that might not be a.
Eating eggs the first time.
As in, like, I did
the
the new thing.
I
I mean, that's not great for your
Eating eggs
grades,
the
but
first
honestly,
time.
that's.
The
It's
first
pretty great
time
for my
I did
grades.
it.
There weren't anything to.
And then I did it
There wasn't
again.
anything assigned.
And I actually
There
did
was some
pretty
stuff that
good
was
at
due
eating
that
eggs.
day to turn in for AMI. Some
Oh, my
of
classroom. It was like
I
one-
don't want to.
there was like one thing that we had to do on the day. Some of it was just do it, but there was like one thing that we had to do.
Yeah, there was one thing I think I turned it in.
Well, not if you did it last. I mean, you probably turned it in last
No,
night,
no,
but not
no.
on time.
I'm saying I did the thing.
Oh, on
Thingy
time.
for Friday.
Yeah.
Yeah, I did the thing for Friday last time. And I think also I worked on the complex fraction thing that I wasn't there for.
I did everything, but looks like they always take too much.
It looks good.
Thompson.
That's a fun
They
show.
always
Looks like you got more than one here for that.
Funny humor.
Yo, Ben, you wanna be in our group? Nick and I for now.
That sounds good.
Huh?
Sure.
I did not read the ASCII or do anything. I have not finished my assignment.
Oh, I did not.
I have 8 more.
I don't even worry about that at all.
The only thing I'm worried about is I just did
Hey, I can do them in the spirit. I'm telling you right now, I can do them.
Did you like it?
So I just didn't do it. And that's the thing I'm worried about. Everything else is pretty easy.
Yeah, I just don't feel ready for this.
The only thing I'm
I
struggling
kinda like it.
or really
It's a
just
nice
not
like in between.
not comfortable with.
Okay, to start off today, I need y'all to get out your limits review, which I believe was from this time last week. The assignment I gave to you at AMI on Monday of last week. I did not give you a number to that, but I am telling you today that it's number 78. So once you get it out, go ahead and number it. And then we'll talk about we need to accomplish today. And wrapping up this unit so that we can move on. So first off, the 3 handouts that you guys picked up, that is actually the same limit review that I had you do during AMI. It's just that I had already printed them off, and so if I just keep them, then I'm just going to recycle them all. So you certainly don't have to like transfer your work over to today's that you picked up, but if you did your work on notebook paper and you don't like it that way and you'd prefer to transfer it over, you're welcome to. And of course, you know, anything that you missed or were struggling with the first go around, you might try those questions a second time. So at least there might be a little bit of use out of those papers. But I ran those copies off long before our snow and ice and stuff. So again, you shouldn't really need those new handouts today, but better than just trashing them. Okay, so as I mentioned on Friday during our AMI that we were really aiming to have our test today, but to be 100% fair to you guys, we wanted to make sure that you had a chance to ask the questions you needed to ask in class. So that's what I'm about to do here in just a minute. So that puts our test next class on Wednesday. And right now you guys are kind of not in a real routine, so more important than ever for you to jot that down somewhere as a quick little reminder. Your test should be about the same length and about the same difficulty as this review. So clearing up the questions that you guys have should go a long way for that. And I don't think that's going to take the majority of class, so you'll also have some class time to put in a little bit of studying if you need to, if you don't feel like you're ready to take this. Okay, questions before I get to this? Okay, then let's just look at it maybe one page at a time. So the very first day, we talked about what a limit was and how to find a limit graphically. And so questions 1 and 2 should give you a quick feedback on if you remember how to do that or not. So either of these two that you need me to talk about again? Just page 1, questions 1 or 2?
This is 77.
78, I believe.
And it's all just these 3 papers.
Yes. You should have already done this. This is one of the AMI days. I'm just giving you the handouts that go with it. You should have already done this on notebook paper or printed out your own copy. That's how I can expect you to know if you need help on these 2 already. So we're good with this? Okay. If I'm moving along too quickly, there'll be plenty of time for you guys to ask some questions later. Okay, I think page 2 is the hardest page in my opinion because there's a lot of different skills here. Limits from a table, limits from piecewise function, a bunch of those. Some limits that are just direct substitution. Some limits that give you 0 over 0 that you solve with factoring. Some that give you 0 over 0 that you solve with trig identities. 0 over 0 that you deal with complex fractions. And 0 over 0 where you had to use conjugates. So we got to space that out and just look at 1 or 2 a day. But when they're all together on one page, all scrambled up, which is how it will be on the test, it adds an extra layer of difficulty there. So I believe 3 through 14 is page 2. So which of these did you want me to talk about with you again? Yeah.
Could you please show me 12?
Or 12? Sure. Okay, so all limit questions, a couple of these and a couple on your test are just direct substitution questions. You have to train yourself to try that first. But on this one, when I plug that in, the numerator goes to 0 and the denominator goes to 0. So before direct substitution works, we need to make this look differently. So again, I just kind of listed off all the different things that we could do. We could do trig identities, factoring, conjugates. What else did we do? Just direct substitution. But none of that really applies to this because you can't do any of that stuff to this piece here. But this is a piecewise, or I'm sorry, complex fraction because we've got smaller fractions within a bigger fraction. So if we know how to make this look different, in other words, if we know how to simplify this complex fraction, we can rewrite it in a way that will be more familiar like other questions. So the trick to this, to make it not be a complex fraction, is you want to multiply by all the smaller denominators. I want to multiply this one by 4 so those cancel. So everything gets multiplied by 4. And I want to multiply this one by x squared to make those cancel. But then they all get multiplied by x squared. And you're left with like 12 minus 3x squared over 4 and x squared and then x minus 2. So the question still has a few more steps to go, but that is what is strictly unique about this question. Going from fractions within a fraction to at least it's no longer a complex fraction. And all I really did was multiply by everything by 4x squared to make those smaller denominators go away. Okay, at this step, you can try direct substitution if you want to, but until something cancels from the numerator and the denominator, you're going to continue to get 0 over 0. So we got to continue to rewrite this in some way. So I think we've done this exact question before, but I don't really know until I just try it. So I know I could take out a GCF of 3 out of the top. I can see that this guy factors. It's the difference of two squares. 2 is being squared on the left, x is being squared on the right. And then these two are almost the same thing. They just have exact opposite signs. Positive 2, negative x, positive x, negative 2. So what did we do that allowed us to make these cancel? Diego, why don't you answer? Yeah, take your headphones off. How do we cancel these?
You just
Sounds like you need to be paying attention too. If you need these both to change, you can factor out a negative, which switches the signs, and then they can cancel. So it's just like a GCF. Pull out a negative, switch the signs, distribute it to see that it's still the same thing. Now that something's canceled, direct substitution should work. So plug it in, you get negative 3 times 4 over 4 times 4, and then you can reduce. Looks like negative 3/4. Now, I'll just be 100% honest. I'm not in charge of putting together the test this year, and so I don't know if a calculator will be allowed on part of it, or none of it, or all of it. But keep this in mind. This is why I really tried to push you this way when we first started this unit. If this happened to be on a calculator part of a test, there's nothing stopping you from, well, you need to know how to do this, and I expect to see your work to get 4 points. But let's say you got an answer of 7. If you graph this in your calculator, and you know how to look at this visually, like we did on the first page, as x approaches 2 from the left and from the right, it should be right around -1. So if you've got an answer close to -1, you probably are going to feel good about that answer. And if you had an answer like 7, you should have a red flag that something's off. So again, I don't know that that will be an option, but if you are allowed a calculator on some or all of it, consider graphing to try to check some of your answers. But this first step is by far the most important, because that step is only applied to this question and does not help you on any other questions. Okay, anybody got a follow-up to number 12? You can do that now? You can do this now? Okay. All right, what else on page 2?
13.
Okay, so if I go through my list of stuff to try, one of the most common one, well, direct substitution, but you get 0 over 0. So the very first day we did factoring, and so technically you can factor the denominator. You don't have to do it right now, but if all you do is factor the denominator, nothing can cancel. So, like the last question, there's a trick to this. There's some algebraic way to make this look different, but it's just not the same trick. It's not the same algebraic thing. So what can we do to this to make it look different? Which rules? What's that equal to? How about that? Okay, so one of the few things you need to remember from last semester is the first Pythagorean identity. Sine squared of any angle plus cosine squared of the same angle always comes out to be 1. So 1 minus sine squared is the same thing as cosine squared. And then, again, this is not a unique question. I think you've done this question 2 or 3 times at this point. So you should be a little more cautious about trying not to cancel these and cancel these. Can't cancel out terms, only factors. But the numerator does factor more because it's the difference of 2 squares. One's being squared on the left, sine's being squared on the right, plus and a minus, and then something cancels, and then direct substitution should work fine. 3 times 2 over 2. Looks like 3 should be your final answer. And again, what question will be on the test? Probably not this exact one, but very likely there'll be at least one question where you need to use a trig identity, like I highlighted in this step, and very likely there'll be one that's tempting to cancel out here, even though it doesn't work this way, and it may factor like the difference of 2 squares, like that step. So I feel like those 2 highlighted steps are the 2 places that if you miss it, there's a good chance that's what happened, one of those 2. Is that enough? Okay. Anybody else want to ask about 13? Have something detailed while still up here? Okay. Somebody else on page 2? Okay. If I'm moving on too quickly again, there'll be plenty of time. The next page, the top half, is about knowing your horizontal asymptote rules, knowing what a horizontal asymptote is, and then understanding how that helps you with questions 17, 18, and 19. So any of those you'd like me to go back over? Again, I think page 2 is the hardest. It requires the most amount of work. Stuff like page 1 and this, even if you don't remember any of this, like this, we did this one day in like 5 minutes or 10 minutes. Very easy to get caught back up on it if you have forgotten it. But okay, then after that, it was a lot about continuity. So you do need to know what the 3 parts of the definition of continuity is. So not just being able to describe it in words. You can't just say there's a break in the graph, there's a hole in the graph, there's a jump in the graph. That's great, but that's not a mathematical justification. You need to know the 3 parts. And then there's a question that gets you practicing why something's continuous or not continuous. And then question 23 does the same thing, and then question 24 does the same thing. So any 21 through 24 that you would like me to discuss again?
Are we gonna have to do like the part D for all these? Like explain?
It would probably be part C or part D, just depending on if it was continuous or not.
Yeah.
But you do need to know the definition to be able to justify those. But if you have this memorized, you're either just picking out the one of them that doesn't work to prove it's discontinuous, or you're showing that all 3 work to show that it is continuous. So if you have those memorized, that's not a big deal. Okay, and then our last and most recent skill was the difference quotient. So you certainly need to know what the difference quotient is. It's kind of like a formula, and then be able to apply it to either a polynomial, a radical, or a rational. Those are the only 3 types that we would hold you accountable for in pre-calculus. Any of those you would like me to do a quick review on? Yes, sir.
We do 26.
26, sure. So to be able to work 26, 27, or 28, again, you do have to know what the difference quotient is. So you won't have to explain to me where it comes from, even though I explained that 2 different times in our AMI, but you do have to have it memorized. Step 1 for question 26, 27, or 28. Step 2, exactly the same thing. You need to understand what this is telling you to do. So first off, this is saying for f of x, everywhere there's an x, plug in an x plus h. So that would be that. And in purple here, it says subtract the whole function. So subtract the whole function. And even though it's kind of a pain because you don't use it till the end, you have to say that it's over h. So those first 2 steps are consistent for all 3 types. What's going to change is how do you go about simplifying this? Well, for this type, we're going to have we've got to square something, a bunch of distributing, a bunch of combining like terms. So we just kind of have to dive into that. So the most common mistake is going to be right here. This is not x squared plus h squared. Now, a teacher that used to work here a long time ago, like 9 years ago or something, used to teach iPrep, I think is what it was called. It was like ACT. It was like a summer ACT program. And he told me that this is, and I don't know if it was true, and I don't know if it's still true, even if it was, but he told me that this was always on the ACT. This question, and this was always one of the choices because they want to see if you fall into that trap. So I don't know if that's still true, but x plus h squared means you multiply it by itself twice, and you have to FOIL it. So it's not just an x squared and an h squared. There's also a 2xh. So if you did this question and you felt pretty good about it, but you were missing a part of your answer, it's probably that. It's probably that you didn't actually FOIL it out. Okay, and then at some point you need to distribute this -4. I'm just going to go ahead and do it now. At some point you need to distribute this negative. I'm just going to go ahead and do it now. At some point you need to distribute this 2. At this point, I guess it doesn't really matter that I'm keeping up with the colors, but oh, also I think I guess I should have started off with this. I think there is a typo on the answer key for this question. That might be why some of you are wanting to see this one. But eventually I've done everything that I could, but there's a ton of stuff that's going to cancel out. So combine like terms. 2x squared minus 2x squared, 4x minus 4x, 9 minus 9. And then everything that you're left with in the numerator should have an h in it, which is good because in these question types, even if you think the difference quotient is difficult, they always, always, always finish the same way. All of these have an h. So I'm going to factor it out like a GCF. And your last step should always be to cancel out the h's. So the answer to this one would be a 4x, a minus 4, and a 2h in any order.
I think the answer key had it 4x plus h minus 4. So that's probably what it was.
Yeah, I think probably what I did was I need to fix it. I don't know if those are my solutions or not, but I think I probably just didn't distribute this and make it 4, because then that would make this. Oh wait, did you say a different number of h's?
I think it was only one h in the answer key.
Yeah, so I must have, if that was me, I must not have distributed this 2 to get that 2h and just thought it was 1h. But again, not to beat you all over the head about it, but in calculus, honestly, what this builds up to, the idea of a derivative, just to be truthful with you, we don't do this in calculus. We do this like one day in some notes because it's important for you to have this understanding of what a derivative is, and so I'd go a little bit more in depth in that in a calculus course. But typically when we need a derivative, we don't do all of this because we probably take 1,000 derivatives first semester, and we don't want to have to do this every time. That being said, this question is very much like a calculus problem, myself included, assuming those are my solutions. Obviously, I know what the difference quotient is. I know how to apply it. I know how to FOIL. I know how to distribute. I know how to distribute more. I know how to combine like terms. I know how to do a GCF. I know how to cancel out factors. But when the questions are long like this, even myself, it's hard to not make a mistake. When there's that many steps, you've got to be a lot more consistent to end up with the right answer. And for some people, that's just one thing that makes calculus very frustrating, because it's like you can know what you're doing, but you're still going to miss questions sometimes just from careless arithmetic or something. So, but again, if you are signing up for calculus, don't think that you're going to have to do this forever and forever. Like, we do this one day in notes, and then we have like 4 or 5 shortcuts that we use. I can look at this and tell you pretty close to what this is without any work. So we've got a few tricks to deal with this. Okay, anybody got any follow-up to 26 before I move it away? Okay, what about any of the others? Now, I don't know. Again, I'm not in charge of putting together the test this year. I don't know how many different quotient problems there'll be on the test, but my guess would be if there's only one, it's probably this type and not these types. I'm not saying that to get you to not study these because they are completely fair game, but polynomials like this are just more common. I'd say if there's 2 of them on the test, it'll probably be a polynomial like this, and then either this one or this one. But this is the more important one to simplify. Okay, then at the bottom, so truthfully, there's probably a couple of these things that you aren't sure if you're really ready for, or you know that you're a little bit shaky on and you know you need some extra practice. So I have collected a lot of direct, to the point, one skill at a time practice for these questions. And so please, please, please take on that responsibility there and get a little bit more practice on the ones that you need. You know, the alternative is I give you, 20 of these for the couple people who need them, and then I give you 20 more of these for the 5 people who need them, and then I give you 20 more of these for the 1 person who needs them. And then you guys end up doing a whole workbook, basically, just busy work. So, reading through these and seeing what question types you struggled with on the rest of the review, consider going and getting a little bit of extra practice on those. Even if it's just 2 or 3 questions before you feel good, then that still can make a difference in your test. So, and I've tried to make that as easy on you as possible. So. Okay, so if you do find something that I can help with that you just didn't have ready, I'd be happy to help you guys while we still have some class time. Unless you feel like you're ready to sit down and take the tests right now, use this time to practice some of those questions again, practice some of those questions on those links at the end, do whatever practice that you think will help move you in the right direction. But we will be testing on this and moving on Wednesday.
On the second page, are
Yep.
is that little line that makes it like less than or greater than or equal to, is that just faded on my page?
Which question are you looking at?
4.
There should be an equal sign here.
It's just, I can't see it.
But honestly, it doesn't really matter. It doesn't matter for limits anyway, because limits don't care what's happening at, well, first off, this is -5, and -5 is somewhere in here. So you could care less what's happening at 0. But even if this had said as x approaches 0, limits don't care what's happening at x equals 0. So even if these were neither one of them included 0, you would still work the question the same way. So, yeah. 15.
Will that be on the test, 15?
Will question 15 be on the test?
Yeah.
Why wouldn't it be?
Um,
I mean, it's really more than likely it's going to show up as these, but it's the same skill.
mhm.
So if you can do these, then you could do this.
Okay.
So this is what you did in Algebra 2. Horizontal asymptotes. This is when you have a rational function, which is just rational basically means a fraction. And you compare the degree of each of these. And if the degree of the numerator is bigger versus if the numerator degree is smaller than the denominator versus if they are equal, you get 3 different types of horizontal asymptotes.
So if we just put that, is that like good? Is that good?
Yeah, I mean, really, I'm being lazy here, but I really should say degree of each one. But
Okay.
if this one's bigger, you don't have a horizontal asymptote. If the denominator's bigger, it's y equals 0. And if they're equal, it's y equals leading coefficient over leading coefficient. The reason why you need to know that is because that's basically the knowledge you need for 17, 18, and 19. Again, you have to know what a horizontal asymptote is, and that's question 16. But because this degree is bigger, I know that goes to 0. And because these degrees are equal, I know this goes to -1/4. And because this degree is bigger, I know that limit doesn't exist. Very easy, quick questions, but it relies on you knowing this and understanding how this connects to this.
Will 16 be on the test?
Why wouldn't it be?
I don't know. How are you supposed to answer it? Helps to understand like in behavior, or
Well, how did I apply this to this? Yeah, I mean, in behaviors, basically.
Okay.
Yeah. I mean, what a horizontal asymptote is, a horizontal asymptote is the y value that the function approaches as x gets really big, or as x approaches infinity. Another way to say is x is getting big, or as x gets really small, which would be when x approaches negative infinity.
okay.
So because these are not approaching something like 5 or 7, they're approaching infinity or negative infinity. That's why what the horizontal asymptote is what the answer to this is. That's the connection between those. And again, even if you don't remember this is a big ACT topic, so you really need to know those anyway. Okay, these are good questions. Keep them coming if you've got more. I'd rather overhelp than underhelp, so. Okay, switch the screen over here then, but again, so you guys should use this time to do some studying, please. Also keep in mind that with our test next class, if you had any work that you did not turn in on time, so there was like, I don't know, we had one AMI day 2 weeks ago from our 1 day of snow or whatever. If you didn't do that, you can still get half points for it, but it needs to be fully completed, turned into Google Classroom, or ready to physically hand in before we start the test on Wednesday. And then There's been a few assignments from last week in AMI that I will take up. So certainly the test review, but probably one or two other things. So you should finish those. If you don't have them finished, you should finish them for the extra practice, but also in case they end up being homework grades to make sure that you get full points on those. So once we take the test, then there will be no more late credit from this unit. So just a reminder there. Okay, if you do find something, feel free to bring it up here to me or call me over and I will help you out.